Here is the solution to Day 1, Problem 1. There's a Part A and a Part B, and they both have to do with a concept called scientific notation, which is a form of writing numbers that uses a 10 and an exponent on the 10 to refer to place value in the number. So let's tackle each part, starting with Part A. Rewrite the number into standard form. 5.34 times 10 to the fourth power. This number is in scientific notation right now, and we're asked to write it in standard form, or as a regular kind of number that does not have the times 10 to the fourth power. And so let's start by copying down this scientific notation number. 5.34 and then times 10 to the fourth power. And we're going to rewrite this as a regular number that does not have times 10 to the fourth power in it. So let's think about what would happen to a decimal number like 5.34 if it was multiplied by 10 to the fourth power. Well, what is 10 to the fourth power? 10 to the fourth power means that you're multiplying by 10 and then multiplying by 10 a second time, and then multiplying by 10 a third time, and then multiplying by 10 a fourth time. 4 multiplications by 10 is the meaning of 10 to the fourth power. So let's think about what's going to happen to any number like a decimal like this if you multiply it by 10 and then 10 again and so on. Multiplying this number by a single 10 would change it from 5.34 to 53.4. A way to think of that is multiplying any decimal number by 10 has the effect of moving the decimal point one position to the right, changing its place value, changing it from 5.34 to 53.4. Okay? So if our scientific notation number is times 10 to the fourth power, we're not going to move the decimal point only one spot to the right, but instead we're going to move the decimal point 4 spots to the right, one time for each of these times 10s. So let's do that. 1 spot, 2 spots, 3 spots. This is going to need to be filled in with a placeholder 0, and 4 spots. Again, this is going to need to be filled in with a placeholder 0. The decimal point is going to end up here with a couple of extra zeros tossed in there as placeholders. That's going to create the number 53400, and then the decimal point. And so the number 53,400 is equivalent to 5.34 times 10 to the fourth power in scientific notation. Okay? Let's do Part B. Rewrite the number into scientific notation. And so this is the reverse of the one we just worked on. Here we have a standard number, a regular looking number, and we're asked to write it as a scientist would, using scientific notation where there's a times 10 and some sort of exponent on the 10. Okay? So for Part B, let's begin by copying down this number, 3725,000, and right now the decimal point is at the very end of that number. Okay? We want to write this in scientific notation, and the key to doing this is to recall that in scientific notation there will always be one non-zero number to the left of the decimal point. There will always be just one non-zero number to the left of the decimal point. Well, here's the decimal point right now. There are a whole bunch of numbers to the left of that decimal point. Let's move this so there's only one number to the left of the decimal point. That means we want to put it here so that the digit 3 is that one number that comes to the left of that decimal point. Well, if we want to move the decimal point to this spot, how far do we need to move it? Let's count. 1, 2, 3, 4, 5, 6 spots. That's going to create 3 point and then 725. We can disregard these extra zeros here and then write times 10. Do you remember how many spots we moved it? 6 spots. So 3.725 times 10 to the 6th power is the scientific notation version of this original number, 3,725,000. Now, day 1, problem 2. Part A, solve the equation. 6n subtract 1 equals 4n subtract 5. We're asked to solve that equation. We want to find a value that we can substitute for the letter n here and here, and then when we work out what this expression is equal to, we'd like it to turn out to be the same thing as what this expression is equal to. When we fill in some number for n, we've got to figure out what number to put in for n to make the left side of this equation turn out to be exactly equal to the right side of the equation. And then in part B, once we think we know that answer, we're asked to check our solution. So let's start with part A by copying down this equation. So 6n subtract 1 is equal to 4n subtract 5. Now, to help keep the left side of the equation separated from the right side of the equation, I'm going to draw a vertical line downward from the equal symbol. This just helps keep things lined up and balanced. Now, we want to solve for the letter n. To do that, we want to get the letter n to be on the left side of the equation, and then some number to be on the right side of the equation, so that when we're all done it says n equals and then some number that's the answer to the problem. So if we know that we want to have the letter n be to the left side of the equation, we don't want to have a 4n on the right side of the equation. Okay? So let's remove the 4n. We can do that by subtracting 4n right underneath the 4n. And then to keep the equation in balance, if you subtract something from the right side of the equation, you have to subtract that same thing from the left side of the equation. 6n subtract 4n makes 2n. The subtract 1 can be brought down by the 2n equals 4n subtract 4n makes 0n, or just 0. There's a 0 right here in the equation. And then the minus 5 can be brought straight down, and we have a minus 5 there, or you might say a negative 5. It's the same thing. Okay? So we have 2n subtract 1 equals negative 5. This is equivalent to the original equation because we did some math but kept things in balance, but it has a different form than the original equation. It's simpler looking. We're closer to having the variable n alone. Here is the n term. We want to isolate the n term. So right now, next to the n term, there is a subtract 1. Let's remove the subtract 1. Underneath subtract 1, write plus 1. And to keep things in balance, on the other side of the equation, plus 1. The 2n can be brought straight down. A negative 1 plus 1, when combined together, makes 0. So there's a 0 right here in the equation. And then equals negative 5 add 1 is negative 4. And so we have simplified our equation even further. It now just says 2n equals negative 4. That's much simpler than the original equation. Up here, we almost have an answer for the letter n. Okay? So our equation has 2n, or another way to think of it is 2 times n. And we'd like to get the letter n alone. We can do that by removing its coefficient of 2. So if this is 2 times n, the opposite mathematics of 2 times is to divide by 2. And so underneath, I'm going to write divide 2, and on the other side of the equation, divide 2. 2 divided by 2 makes 1n equals Negative 4 divided by 2 is negative 2. And so we have 1n equals negative 2. And 1n is just the same thing as an n equals negative 2. So here is the answer for n that we think is correct. We think that n has a value of negative 2. In part B, let's check and see if negative 2 really works. If we take negative 2 and put it here, and put negative 2 here, and we work out this expression and this expression, do they actually turn out to be equal to each other? Let's find out. So 6, and then in parentheses, we're going to substitute or replace the letter n with negative 2, which is the value that we think should go here. And then there's a minus 1 equals. And now over here, 4, and then for the letter n, let's fill in negative 2. So 4, parenthesis, negative 2. And then there's this minus 5 on the end of the equation, minus 5. Okay. Does this expression that's to the left of the equals really equal this expression that's to the right of the equals? And if it does, then we have the right answer for n. So let's find out what these things equal. 6 times negative 2 is negative 12. And then there's the minus 1. And negative 12 minus 1 is negative 13. Let's figure out what the right side of the equation is equal to. 4 times negative 2 is negative 8. And then here this minus 5 can be brought down. And then negative 8 minus 5. That's negative 13. And so does negative 13 equal to negative 13, we're wondering? Well, yes, it does. And so this checks, and that means that n equals negative 2 is the correct answer for this equation.